And the last one, again, we're going to do a 95% confidence interval. Okay, so one of the two fire stations in a certain town responds to calls in the northern half of the town, and the other fire station responds to calls in the southern half of the town. One of the town's council members believes that the two fire stations have different mean responses. Response time is measured by the difference between the time an emergency call comes into the fire station and the time the first fire truck arrives at the scene of the fire. Data was collected to investigate whether the council member's belief is correct. A random sample of 50 calls selected from the northern fire station had a mean response time of 4.3 with a standard deviation of 3.7. A random sample of 50 calls selected from the southern fire station had a mean response time of 5.3 with a standard deviation of 3.2. We're going to construct and interpret a 95% confidence interval for the difference in mean response times between the two fire stations. Okay, so let's just make sure all the conditions are met. It did state that it was randomly selected. Check. Both, again, since we have two samples here, we're basically saying that the difference in time compared to the northern and the southern fire stations, they are in fact both sample sizes of 50, which is in fact greater than 30 on both. So again, that proves normality. And independence, we can assume 50 calls, again, both of them are 50, that's less than the 500 calls that any fire station would get. Okay. Now this one again is not a paired t-interval. This is actually two samples. They don't come from obviously the same one. One's from the north part of town, the southern part of town. Again, here are the stats. The mean is 4.3, standard deviation 3.7. Again, sample size was 50. That's from the northern fire station. Southern one was 5.3, 3.2, and sample size again was in fact 50. The councilman is claiming that there is a difference, which you see the average time is in fact different, but again, we can never go off of that because of those is from samples, and we don't know, again, anything about the two parts of the town. Okay, so in this one, we're going to do a two-sample t-interval. I don't have this written out here, so please watch this video. You want to pause it and stuff so we can find what proper tests we're going to take. Oh boy. I'll clear this out. I have the other one I just did before. Okay, of course, we're going to go to stat. I'm going to scroll to test. Now, on this one, we don't just go to t-interval because we have two samples here. Again, the northern station and the fire station. So we're going to scroll down to past 9, 0, and that's a two-sample t-interval. Again, all the means, again, we're doing t-intervals. All right, again, we have two options here, data and stats. Again, what we have in this question is statistics. We have a mean, we have a standard deviation, sample, yada. So I'm going to stick that on stats. If I was going to have data, I would obviously have to import them into, a list, and I could do it that way just as well. Okay, so on this one, the northern one, I'm going to input the data. I'm going to put it right here. 4.3 minutes average time. And it deviates again by 3.7 minutes. Again, that was 50 calls from that sample. Again, the southern one, they had an average time of 4.3, and it deviated by 3.2. That one was also, in fact, 50. As we scroll down on this test, which the other one didn't have, again, we're doing a 95% confidence level, and again, pooled, being that there are two samples here. We never pool, okay? There's nothing ever in this course that we're ever going to pool anything. And calculate, let's find what that's going to be. Again, there's two samples here. Okay, degree of freedom. You do not want to see how to do that by hand. So we should be very happy we have these calculators. Again, here's all the statistics listed below of what we already knew. Again, so here is our confidence interval for the difference of those two fire stations. And that was, in fact, again, northern minus southern. All right, so I'm going to write that again in my interval right here. And, oops, I'm sorry. I'm just going to round off. Negative 2.37 and 0.37. Okay, and that is the difference in time from the northern minus the southern fire stations. So there's our interval, and of course with every interval comes an interpretation. I don't have it here, sorry. We are 95% confident that the mean difference in response times is between negative 2.37 and 0.37 minutes. Okay. And just like the last one, a little different now though. Part B is then asking us, does the confidence interval in Part A support the council members' belief that the two fire stations have different mean response times? Explain. Okay, so this all goes off this interval. They're basically looking to see if 0 falls in the interval. This time it does. 0 is within the interval, so this does not support the council members' beliefs that there is a difference between the two fire stations. Remember, if 0 does fall in the interval, that is basically implying that there's no difference. No difference between the call times of the northern fire station, no difference between the call time of the southern fire station. And that is because 0 does in fact fall in the interval. This will also kind of lead us up when we do hypothesis testing next week, the significance level. We can answer the same question on whether we stick with the null or go with the alternative. But we're doing the same thing again. We're doing it straight off the bat with confidence intervals. So here again, 0 does fall within the interval. So again, there is no difference. 0 implies no difference.